emailed Todd earlier and said, hey, listen, if I'm not here in 15 minutes, then please help. Right,
That's all good, Paul. Happy to join.
Thank you very much. Right, we are live on YouTube, I think. We're a few minutes out, so we will go live on Twitter. So that's going to go.
Here we go.
It's amazing, isn't it? I'm sitting in my garden at 1 a.m. and streaming to multiple services at the same time.
It's fantastic. It's absolutely, I mean, it's just the sheer, sometime I'll have to tell you about my amateur radio forays as a youth, but it's a great feeling. I've always enjoyed connecting globally, and it's just such an exciting thing, such a rush.
Anyway, hello everybody, because if you are watching in internet land, here we are. We're going to start in a couple of minutes time. It's interesting. It's refusing to let me share that tonight. Look, there we all are. There's a few Slooh members there. So, what's happening there?
You never had video mic back in the days, though, with your radio.
Oh yeah, no, great question.
Folks, let's we are public tonight, so we need to keep the natter down to a minimum because other people watching in won't really understand. We're going to start off in a couple of minutes time. Don't forget, we have got the moon show later on as well. That's in 2 hours time.
Oh boy, that's a long night.
Yeah, that's in 2 hours time. And then of course we've got the big Perseids Meteor Shower tomorrow night as well. So we're going to kick off in about a minute's time. Can everybody see my screen, by the way?
Yes.
That's always a good start, isn't it? Always a good start. Hey, I'll tell you the other thing that I haven't done, which I need to do. We need to hop over here. This is the Slooh website that we're looking at now. We need to hop down. We need to hop down to star parties because at the top of the hour, we need to make sure that here it is, Star Party live, shooting the Perseids, and there we go. We are live on the website. So I think that leaves it to say welcome, everybody, not just Slooh members tonight. We have got a public show tonight. So we're on Slooh's YouTube channel. So welcome if you're watching there. Also on Slooh's Twitter feed. I'm Slooh Astronomer Paul Cox. We've got a whole bundle of Slooh members joining us. Slooh members can actually join us in the webinar, in the Zoom webinar. So it's great to see all of them. Wave everybody, quick, before you disappear. Yay! There's loads more coming in as well. So anyway, we also have, well, I say he's a guest, but he's more of a Slooh friend really. But he is a world-class astrophotographer, and it's Dr. Mike Shaw. Hello, Mike.
Hello, Paul, and hello to everyone who's joining us this evening. Glad you're here.
Now, we are going to be shooting Perseids tonight. What does that mean, Mike?
Great question. So as you've probably gathered, and the reason you're here is that we are on the cusp of the annual Perseids Meteor Shower. We're going to hear all about that tomorrow night in a full-on show. But tonight we're really focusing, no pun intended, on Perseid photography. So we want to make sure that tonight you can set up your camera tonight and tomorrow night and capture your very own image with a Perseid meteor in it. So you're going to learn about the camera gear, the settings, the best time of night to shoot, the best direction to shoot, best lens to use, and all that good stuff. So we got a lot to talk about, but it's really all about the photography tonight.
Exactly, and I think what we're going to try and do as well is we're kind of start off with intro, basics, stuff like that, and then if anybody has got any questions, then over on the Slooh website you can ask those in chat, of course. Just put your questions in here, and we'll get to those a little bit later. But if we've got any kind of more advanced questions, Mike, I think we should kind of leave those until the end of the star party. Now, anybody out there in internet land who doesn't know what Slooh is a worldwide community of astronomy and space enthusiasts. And we kind of do astronomy together, social astronomy. So we're normally kind of gathered around Slooh's telescopes in the Canary Islands and Chile. We may as well actually take a little quick look at those before we get into it. But we also do special things like this. And Mike runs the Slooh Nightscapes Club. And Mike, you do a weekly show on that, and you're helping people with DSLR cameras and mirrorless cameras photograph the night sky. And that's kind of what we're going to be looking at tonight. Now, the Perseids Meteor Shower itself peaks tomorrow. So we've got our main Perseids Meteor Shower tomorrow night. That's Wednesday. That starts at 7 p.m. Eastern time. That's 2300 UTC. So make sure you join us for that, because we've got some epic feeds going through. I saw some tests tonight from the Canary Islands and from Sharjah, also here from the UK as well, hopefully, if the weather cooperates. But I think, Mike, would you mind, before we get into some Perseids photography, shall we have a quick look, see what's on the live on the Slooh telescopes tonight?
Let's do that. But Paul, I have to, just for the benefit of those joining us, it looks like you're outside. Why are you outside, Paul?
Well, I'm outside because it's incredibly hot here in the UK. No, that's not the reason. I actually came out because tonight was going to be a really good test. This little show was going to be a great test of my Perseids Meteor Shower video feed tonight. But if I do that and blank out the glare from my two monitors sitting out here in my garden, it's cloudy. So unfortunately, we haven't got any early views.
Okay, well, we'll keep our fingers crossed that it clears up.
Who knows? Who knows? But anyway, hey, Mike, have a look at this. This is
we go.
So if you don't know anything about Slooh, you've never seen us before, this is what Slooh members get to enjoy every single night. These are live views from the Canary Islands telescopes. It's at the Institute of Astrophysics of the Canary Islands. This is our Canary 1 telescope. It's a 1/2 meter telescope, which is enormous, slightly larger than the kind of lenses we're going to be talking about on DSLR cameras this evening. But here we can see a star-filled, beautiful kind of stars, and this looks like a very large, dense cloud of nebulosity. This is not one that I'm familiar with, so that's an interesting one. Let's have a quick look at the Canary 2 telescope, see what's in there. This is the second largest telescope over there.
So Paul, all these buttons along the top of the screen are all the different telescopes that Slooh has.
That's right. So we've got 2 down in Chile, Chile 1, Chile 2. We've got Chile 3 is used for special events, video camera. We've got the Canary 1, which is this 1/2 meter telescope. Canary 2 is looking pretty good. Canary 3, Canary 4 is our solar system telescope. So this is somebody who's collecting not a particularly photogenic mission. So these are live views coming in from this telescope. SAO, that's a star catalogue, Smithsonian Astrophysical Observatory. Oh, look at this, Mike. You recognize this. Go on. Before we go into DSLR, because actually this is quite a good target if you've got a DSLR camera. What are we looking at here?
Well, this is a great one, because this is one that is not too different from, not too far away from the Perseids meteor showers. So
Exactly,
looking in the northeast sky in the northern hemisphere, you're going to see M31, the Andromeda Galaxy, and some of the images that we'll be sharing later on tonight, you'll be able to see this. And what's remarkable about, I was about to digress. So yes, that's the beautiful Andromeda Galaxy that's available through the Slooh telescopes.
Exactly. Now, Mike, let's use this then. So that is a live feed, right, coming in from the Slooh Canary Islands Observatory. So there's the core of the galaxy. All of the stars that we can see there, those are in our galaxy, the Milky Way.
Oh yeah, this is a great thing. So for those new to this, and I hope you're finding this as just fascinating as I do, when you see a view like this, it kind of looks like everything's muddled together with this bright object in the middle. But the analogy that I like to bring to this occasion is it's kind of like when you're driving your car or you're on a bus or something, or you're inside your home and there's raindrops on the window. And when you look through the window, you can see things that are outside of your window, but you have these raindrops on the window. And so all these stars that you see here are like the little raindrops. They're the stars in our galaxy. But that thing that you're looking at on the screen, on that Paul's sharing it with you, is actually a completely separate galaxy that's way on the other side of the street. It's just, and it's amazingly far away, but
we can see the dust lanes now coming out. Yeah. But, you know, let's go back then to the Perseids, because you mentioned the Andromeda Galaxy is really quite close. Now, here we've got our star chart here. That's where the Andromeda Galaxy is. Here we can see a very distinctive W-shaped constellation, Cassiopeia. And if you point down from these two stars here down to the left, there's a couple of double clusters there, which are great looking through binoculars. But then just over here is a constellation of Perseus. And that's where these meteors appear to emanate from. But if you want to photograph them, let's get to the basics, really. What's the basic equipment you need, Mike, to be able to do some nightscape photography?
Great question. It's always a good place to start. So we're going to leave cell phone astrophotography aside, because amazingly, some of the later cell phones are very capable of capturing night photography images, including the stars and the Milky Way. But really, the only thing you really need to have is a DSLR camera, digital single lens reflex camera, or a mirrorless camera with a manual exposure setting and a manual focus capability. And most cameras these days have that. So if you have a camera, chances are you are able to take night photography images tonight. So with that camera on a tripod, because you're going to have a long exposure and you won't be able to hold it in your hand steady enough for the amount of time that's needed, you're good to go. So really just a camera and a tripod, and this is the information you're going to hear about tonight, and you'll be able to go out and get some and start your journey down the rabbit hole of night photography.
And loads of patience to learn, and of course a Slooh membership, so they can watch your Nightscapes star parties every week to learn how to use it. Now, to do it at your kind of level, to do nightscape photography at your kind of level, Mike, you have to have oodles of experience and a lot of patience, and you have to do lots of post-processing and stuff like that to your images. But what I always try and impress on people if they're starting out is actually it's a lot easier than you
Absolutely
think. So think about somebody who has got a DSLR camera, didn't even know they could use it at night. What would be some basic settings just to try it out on a
just to try it out?
Yeah, so go out in the evening, have it set up on the tripod before it gets dark. Don't be fumbling around in the dark. Take your setup out on the tripod, point it up to the sky. Give us some basic settings for people to try. You mentioned something about manual mode.
Yeah, so essentially there's two things that are really important that Paul just mentioned. And the first has to do with the focusing, because most of the times we use our camera and it has an automatic focusing capability built in. And that totally does not work at night. So you need to turn that off and switch it over to a manual focus. So in my camera, there's like a little setting on the lens here that allows you to set that. There's a little setting in here that allows you to set that on the camera body. But if you have a camera manual, or you can poke around on the internet, it's pretty easy to find out how to set your camera so that it's on a manual focus mode. And then we're old school. All you do then is you literally, there's like a little ring here. I don't know if you can see it on the this ring, how that moves there. That's the focusing ring. And as I adjust that ring, I focus in and out of the on the object. So like Paul said, preferably take it out maybe in the evening and focus on something really far away, a cloud or a mountain or a building, and then leave it. And then once you've set that focus, it's pretty good. You can just leave it for the rest of the night and you're all set for your focus. And then in terms of the exposure settings, you're going to want to switch it to a manual exposure. So a lot of times you're going to be shooting an automatic exposure or program mode or aperture priority. But this is the time to go to manual exposure. And there, once you're in manual exposure, there's three things you're going to want to know about: the ISO, the aperture setting, and the time of the exposure. So for the ISO, I would recommend an ISO of 3200 and an aperture of f3.5 and an exposure time of between 10 and 20 seconds. So, that's a good starting point. It's just a recommended starting point. If you're in a bright location, you're going to want to bring your ISO down to maybe 800. If you're in a dark location before the moon comes up, you could go up to 6400 or 12,800, but that'll get you going.
Right. So there's some basic settings. Let's, Paul, your voice is a little soft for the live stream.
I think you're trying to not wake up your neighbors, and we respect that.
I am, exactly. I can turn up some gain. I'm glad you understood what I was trying to do that night. Yes.
Well, it's all about, I mean, I was doing a thing the other night at a place where I had a special permit, and the law enforcement came by. So I got this wonderful time lapse, and about a third of the way through, I have the red and the, you know, the flashing lights. So I think that would be kind of a fun addition to the show tonight.
It would. Anyway, sorry, I got distracted there. If you have got any questions, by the way, then you can pop them up there. Am I loud enough though, everybody? You can actually hear me.
I can hear you fine. I had to turn up the volume a bit, but your voice is very clear. But it's I'm glad that the Space Foundation Discovery Center pointed it out, because it is a little.
I do have a. Is that louder? Is that louder?
Yes. Yep.
It is. Okay.
Yeah.
So just turn up the gain. I had actually turned it down. But anyway, Mike, you mentioned, so that's the first night out. You're going out now. You mentioned these three things. Now, some people even who own a DSLR camera will not necessarily be aware of what those three things are. I mean, exposure duration, I think, you know, that's how long the shutter is open, how long you're taking the exposure, you're taking the image. So I think we've probably got that one. But this aperture setting that you're talking about on the lens, tell us a little bit more about that and the numbers that people should be looking for.
Absolutely.
I've got a lot of people, exactly the same as me, you buy a DSLR camera. Actually, I do want to just say, to do this stuff, if you want to start off and you want to start off cheap, go onto eBay, find a Canon, probably 450D or a little bit later, find one with a broken flash, you can pick it up for $100 or less. That's the entry point for starting off some nightscape photography. And I'll tell you, the kind of images that you can get out of that with Mike's assistance and artistry is absolutely mind-boggling for $100. But most of those cameras come with what's called a kit lens. So Mike, those are normally kind of variable zoom lenses.
That's right.
They're not perfect quality, but they are more than capable of doing some pretty decent night.
Oh, and they're perfect for the Perseids because they tend to be on the wider angle of things, 18 millimeters to 55 millimeters.
So that's the what, the focal length?
The focal length, right? So that's that refers
to how much sky it sees.
How much sky you can see. So the one thing to bear in mind is everything in photography is opposite from what you expect. So a smaller number means more sky. That's right.
Okay, so you know you're going to, for the Perseids, certainly want to zoom out as much as possible. So what about the aperture then? You were talking about f numbers. What are most of those lenses? What's the range? And once again, those numbers in kind of reverse logic order. What's that about?
So the sort of the golden settings for night photography would be for the Perseids tonight. For most people, I would say would be an ISO of 6400. We'll talk about that. An aperture or an f-stop, same thing. Aperture and f-stop, same thing, more or less. Of let's say 3.5 or 4.0. I'll explain what that means in just a sec. And then, like Paul was saying, a duration of the exposure is around 10 seconds or 20 seconds. Now, here's how this works. So if you're going to want to make a photograph of any type, you can think of it using the famous firefly analogy or lightning bugs, if you will. And so basically what the ISO does is it tells you how many of these little insects, or even honeybees, or how many of these little insects do you need to make a decently exposed image. And for a high ISO, let's say 3200, you don't need very many. You only need a few. For a small ISO number like 100, you need a lot. So at any rate, the ISO basically tells you the sensitivity of your camera and how much light you need in order to basically render an image. And so because we're shooting at night, everything's dark, there's not a lot of light, we always tend to shoot at higher ISO numbers like 3200 or 6400. Now, the question about the aperture and the shutter speed, it goes like this. Imagine that you have all these bees. It's like you have this like a cloud of bees and they're all trying to get into your camera. Well, if you have a small aperture number, you have a large opening. So the aperture is the opening of your lens, and you can let a lot of bees in. And that's what you want to do for the, I'm getting distracted by these beautiful images.
I don't want to let a lot of bees in, Mike. Most people don't want to let a lot of bees in.
Well, you do if you're shooting at night, because these little bees, of course, are photons of light. And so when you have a big wide open aperture or a small number like f3.5 or 4, you can let a lot of them in all at once. And that's what you want in night photography. And then the shutter speed simply refers to how long you open up the garage door to let the bees in. And it's really that simple. So it's like, how big is the door? How long do you leave it open? And how many of them do you need in the first place to make your image? And that's what those 3 parameters of ISO, aperture, and shutter speed refer to. So again, the golden numbers are 3200 ISO, an aperture of around f3.5 or f4.0, and then a shutter speed of 10 seconds or 20 seconds.
Yeah, I was just showing actually, while you were talking about that, some of the Nightscape shots that members have shared in the Nightscapes club.
Oh, there's some great ones.
There's some absolutely terrific ones in there. I noticed as well, you've got your book up there as well, actually. So, in one of your posts. What are we looking at here, Mike? While we talk about the Perseids Meteor Shower, what are we looking at in the Canary 1 telescope? This is a live view coming in from the Canary.
Well, this is a little different. This is what we would call a deep sky object for those of us, starting out. And this is it's a planetary nebula. It's a sort of the remnants of a dead star or a dying star. And you see these little ghostly circular rings that are there in space. And it actually is like if you can imagine, it's like an hourglass looking along its side. So we're actually seeing these 2, amazing elongated shells of gas that have been ejected from this star. But when the color comes in, it's pretty neat. But this is a pretty difficult object to photograph. So this is where Slooh is so great, because you can sort of sometimes barely make out these little planetary nebula in your Nightscape images, but through the Slooh telescopes, I mean, they're the main attraction.
When this goes color, well, our jaws will hit the floor, I'm sure. Mike, you were talking about ISO there. Mm-hmm. Now, we don't want to delve too far into this, but ISO in the old days, you used to buy film.
Oh, yes.
And it used to be a certain ISO rating.
Absolutely.
They've kind of carried it over into digital cameras. But how do they make it more sensitive? And what's the downside of, if you want to shoot the faintest possible Perseid meteors, and surely you'd ratchet, my camera goes up to over 200,000 ISO. Why wouldn't I just whack it on there to capture the faintest possible objects?
Great question. So and you're absolutely right. Back in the day, for those of us who used to shoot film, you would you would buy ISO like 100 or 200 or 400. Those were basically it, or ASA, same thing. ISO and the ASA was the same sort of rating system. And of course, you use ISO 400 for your indoor shots, and then the ISO 100 for the outdoor shots. And it's pretty much as simple as that. And the difference there was how the film was made in order to detect the light based on the particles on the film, on the emulsion. And the same kind of thing carries over in a way to digital photography. And to answer Paul's question, and it's germane, is that the downside to high ISO settings on your camera is it's kind of like when Paul just turned up the gain on his voice, you heard a lot of crackling, and it didn't sound as clean as a low gain that was clear. And so low ISO cameras low ISO images tend to be very clean and sharp and not have a lot of digital noise or speckling or mottling in the image. If you zoom in and you look at some of these images, you've probably seen this, all of you who are watching this, when you zoom in on some images, there's like a little kind of unpleasant like color speckling, there's color noise, there's just like, it looks like a salt and pepper type thing. It's kind of it's just where there should be a uniform gray, it looks kind of speckly. So that's an artifact that's introduced by using high ISO. So there's an eternal debate in night photography communities about benefits or the the pros and cons of using high ISO, but the verdict is pretty clear that higher ISOs have more of a pro than a con. So that's why they're recommended. Whereas you wouldn't necessarily do that if you're shooting a birthday party at noon on a sunny day, where you use an ISO of 100.
Are there any kind of conditions? Oh, here we go. The Helix Nebula going into.
There we go. There we go. Everyone stop what you're doing and look at the screen. Here we go. Look at this. You can start to really see those two set of rings coming in. So Paul, tell us a little bit of, I'll put you on this. Tell us a little bit about the different colors. Why are some areas red and some areas of bluish green?
Different gases in that.
Different gases.
Cloud. And
that's incredible.
We know that when they're excited by the ultraviolet light, I think it is, and the remnant of the star that's left at the core of this is what's going to happen to our sun. But when those gases get excited, they emit different wavelengths of light, and different wavelengths of light mean different colors.
So they're actually different types of gas.
And dust and elements and all sorts of stuff being created in there. Of course, you know, this is, as you say, a planetary nebula. I mean, this is a sun-sized star. Stars kind of below about 8 times the mass of our sun end their lives in this, actually it looks quite violent, but actually it's quite sedentary. It's kind of puffing off its outer atmosphere. Larger stars, so stars with masses greater than 8 solar masses, 8 times the mass of our sun, they go bang in a slightly
different
way, don't they? We get there, and
but before we
stuff made, don't we?
Before we leave this, I want to make a connection to the point that you made earlier with the Andromeda Galaxy. So I'd like to draw everyone's attention to the stars that you can see overlaid on the colors. So it looks like the colors are behind some of the stars, and in fact they are. And this is a little object that's in our Milky Way galaxy, and it's sitting there in space. You know, maybe it's on the other side of the street, maybe it's on the street after that. But we're looking at a 3-dimensional object here. I mean, we have these stars in between us and the Helix Nebula. Then the Helix Nebula is blocking out some of the stars behind it. So this is a very 3-dimensional view that we're looking. Oh, there it goes.
Yeah, I was just going to say that if anybody, you know, if you're new to Slooh and you want to find out more about any of the objects, and you know, we've got tons of information. We've got members sharing their observations here that they've done. We've got information about the visibility of the object. We've even got things, art and culture and things like that, and related objects about them. So, and shows that we've done related to them. A guide to planetary nebulae. So if you wanted to learn what a planetary nebula is, and you can hop over to our guide and do that. Oh gosh, look at that. There's the Ring Nebula there. Oh look, come on, we're digressing. We are shooting Perseid meteors tonight. So it's not just about how to set up the equipment. It's where you point it as well, Mike. Now, we were talking right at the very beginning, you know, about Perseid meteors. They look like they're emanating from, oh, look at that. Oh, captured a satellite. Captured a satellite in this particular Barnard's galaxy, very faint, dispersed galaxy, which is just fuzzy patches there. But this line coming through it, quite often members see a line like that going through an image. Oh, it's a meteor. Unfortunately, no, it's not. It's very rare to capture a meteor in the live telescope.
Oh, yeah.
Because the field of view of the telescopes, how much sky we see is really quite small. But we do often capture satellites, and you can tell this is a satellite because you can just see it gets brighter and fainter and brighter and fainter. That's because a lot of satellites are actually spinning. So their reflectiveness changes during the long exposure of this particular telescope feed. So anyway, won't digress onto that. But so we talked, Mike, about the radiant. They're called the Perseids because they appear to emanate from the constellation of Perseus, the hero. So if you're going to photograph these things, I guess a lot of people might think pointed at the radiant, and I'll capture most Perseid meteors. Is that the place? So talk about composition for us. Where to point?
Definitely. Well, let me just give a preview of the. Actually, let me just. I've got some images I want to share tomorrow night, but let me just share some images that I captured, if I could, this morning. So this was roughly just after hot off the press. So there's a little. I'm going to try sharing my screen, Paul. So if I lose everybody,
okay, we'll see you tomorrow if we lose you.
We'll see you tomorrow. So
I've just noticed, Mike, you need to refocus your webcam, so that we can see your books. It doesn't matter if you're fuzzy, but we should at least be able to see your books in absolute focus.
Well, I'll be sure to do that for the show for tomorrow night. So the image that you see here.
I can't see anything at the moment. Can anybody else see Mike's?
So I have an indication that my screen is being shared, but anyone see it? I've got a thumbs up.
Yeah, we can see.
Good, Paul. You can. Thanks, Yari. Paul, you can see it?
No, it's just me. Maybe because I'm running.
That's a shame. Okay, well, I'll just go ahead and point out that for those of you who can see it, can you see my cursor? Okay, thank you. So obviously this is a meteor here, and this green part is the end or the tail of the meteor, and this bright part is the head of the meteor. And as you'll hear, we're going to learn a lot about meteors tomorrow night, so I'm not going to digress there. But if you look up here, this thing right here is the Andromeda Galaxy. Okay, that very faint object there. So I think let me try zooming in. And there, can you see that? I think I have just enough resolution. You see that little fuzzy patch? So that's the Andromeda Galaxy, and that's what we were looking at. So we could probably match up these stars that Paul was showing us just a minute ago. So that's one of the very few things that you can see with your naked eye in a dark location. It's several times the diameter of the moon. And so it's not a small object, but as Paul was saying, it's close to the radiant. Now, the constellation Perseids is down in here. And so you can see, actually it's down here and a little bit up here. You can see the double cluster right here. So you can see how this meteor is shooting away from that part of the Perseids. So if we had a lot of these images, if someone took a lot of photographs over the course of last night, let's say hypothetically, you could put them all together and they'd all be shooting out from that point. Now, in contrast to that one, what I'd like to do now is to share a different one also from this morning, but this one is from pointing in the opposite direction. And so what you can see here is a meteor like that. So working a little bit on the color. So the red color you see, Paul, can you see that one?
Yes, I can, yeah. Okay,
so the red color is an artifact of my processing. So that's a Mike Shaw problem. But underneath it down here is the city of Minneapolis and St. Paul. You can see Jupiter, you can see Saturn, you can see very faintly the Milky Way galaxy. It's very washed out because this is a very light polluted. It's part of a project I'm doing with a local museum on light pollution and how it affects our visibility. But in any event, the key point here is in this case, remember the other meteor was shooting up. This one is shooting down because we're looking across the other side of the sky. So this meteor actually came arcing over our head before it came into the atmosphere, and then it came scorching down towards the horizon. So when Paul was asking about the compositions, I would suggest that those are the two main directions to look, either towards the radiant roughly, directly away from the radiant like you see here, or roughly 30 degrees, 90 degrees to the sides. Sometimes you can see them coming to the side. But you can really imagine these things. It's kind of like one of those, time travel science fiction things where these things are shooting out from the radiant. You can look into the fire hose, you can look sideways, you can look behind you and see how they're shooting overhead. So you really can't lose. They're visible all throughout the sky. But actually looking into the radiant, they can actually be a little bit shorter. Sorry, guys.
Yeah, exactly. And I have to say that when I am shooting meteor showers myself, normally just for live video, I do prefer to, I'm not about composition and getting something of the landscape. I'm usually just trying to capture as much sky as I can to show millions of viewers some lovely shooting stars. and making lots of wishes. Let me just have a look. No, it's still cloudy. So I do tend to try and get quite a long way away from the radiant because, as you say, Mike, you know, when you're looking at the radiant, you know, they're coming almost towards us, so their trails are very short. The further away you get, and in fact, you can get some incredibly long trailing ones, the ones that are almost skimming Earth's atmosphere, and they can leave an enormously long trail. So we know where to point our camera. We know the settings that we need to use. What else do we need to know, Mike, to go out for a successful Perseid meteor shoot?
Right. So here's what I would recommend for this is a long event. And so this is an all-night event. And in fact, this is a past midnight event. So as you'll hear during the show tomorrow, we're going to talk why these are the why what I just said is that way. But the key thing what I would recommend for a successful meteor shower shooting is to shoot as many images as you can. I mean, like literally I had 3 cameras shooting last night and each of them shot 1,200 images. So I've got almost 4,000 images from last night to go through. And out of those 4,000 images, I probably have a dozen, you know, really nice meteors. And that's typical. I mean, that's you know, it's, we have the moon coming up, we're going to talk a little bit about. So how do you do that? Well, there's several different ways. One is you can just, you know, keep pressing the button over and over again. But there's another way.
I like that, Mike. Isn't that the old-fashioned kind of air bulb, you know, where you had to put the glass slide in?
Yes.
This is how
you mean with this?
You are. That's the one. Yeah.
So you can do that. But there's a more sophisticated way. And if you look carefully, this thing has a locking mechanism. So what you do is when you push this down like so, you can lock it so it stays depressed. So now this is basically on. And so here's the trick. If you put your camera so that it's in a continuous shooting mode, it'll just take pictures all night. Then you can just go to sleep and wake up and, you know, get your camera full of pictures. So this is I call that the paparazzi mode, by the way. So what's a continuous shooting mode is if your camera has you know, so if you like, you just hold the button down and it just continuously fires.
You just sound the game for us, that Mike?
Well, I don't know if that would translate very well, but in any event, so that's certainly one way to go. Now, your camera may also have, in fact, it likely has a built-in intervalometer. You can buy a fancy, you know, external intervalometer. So this is a programmable thing that you can program in to basically control your camera to take 20-second pictures all night. Or if your camera has in the shooting menu, it may have a program. Oh, here, look at, I wonder, what are we looking at here, Paul? Oh my God, look at this. This is amazing.
I don't know. I don't recognize it.
Love that.
One to recognize, isn't it? If only there was something on the page that told us what it was. It's looking a bit crummy, actually. I wasn't going to.
I think it looks great.
That is Saturn. I'm still going to take a snap of it.
Yeah, no, you got to do that.
Yeah, so this is the gas giant, the ringed Saturn. Its opposition. It was very close to Earth at its best, really.
Nice tilt to the rings.
Ago. It looks like the seeing is not great in the Canary Islands tonight. We'd normally start seeing more detail, especially when it came into color. So we'll stick on it anyway. But Mike, you were mentioning about you know, imaging all night. Don't forget, folks, you can ask us any questions in chat. We'll keeping an eye open there. You're talking about, you know, setting your intervalometer up and taking shots all night, but DSLR cameras run on batteries.
Oh, yes.
Get cold when you're outside, so they don't last very long. So certainly when I'm doing any of this, I hook all of mine up to either larger power packs, or usually I try and get close enough to some mains. I know you go out on the you know, in the middle of the wilderness sometimes for your shoots, but having sufficient power is really important, isn't it? If you're planning a long night shoot.
Right, so it is. So in fact, in this camera, you may notice that, I'm glad you mentioned that, Paul, because this has a separate battery pack. So there's essentially there's a battery inside the camera, there's a battery inside here. And the point that Paul made is actually super important in terms of temperature, because here in Minnesota, I mean, right now it's warm. I mean, Paul mentioned it's a hot night in England, which is probably about 15 Celsius. You know, it's this real scorcher, but here in the U.S. But you know, we're always plagued with something. It's never super easy, and the issue right now with us is dew and condensation, and so part of the routine is to take these disposable hand warmers and literally tape them all around my lens and all around the camera body, and that keeps the camera lens warmer than the environment, and it keeps the dew off the lens. And as Paul was saying, if you are shooting from a cold environment later in the year, I often wrap these around the camera body to keep the batteries warm. I'll wrap the whole thing inside another plastic bag to make a little cocoon, and anything you can do to keep the temperature up for those batteries, because you're right, they do fade out with time.
And you can get electric dew shields and bands that you put around that keep the optics just slightly warm. Mike, do you do you put a shroud on, or do you put your lens hood on to try and reduce that dewing?
Yeah, that's another great tip. So I'm trying to see if I have one. So yes, in essence, the lens heaters work superbly well. A lens hood works well. They don't work very well. Now in this particular camera, you can see that the lens hood is not very big because it's a wide angle lens. So you can really see, I mean, if you can see the glass, it can see you, type of a thing.
Yeah.
And so if I put something over this, so that's kind of a thing, but absolutely for the medium telephoto lens. And the reason for that, why do things get dew in the first place? It's really an interesting thing, because without digressing into the whole issue of radiant heating and clear nights versus cloudy nights, I'll just say that your camera is very efficient at radiating heat into the night sky. And when it does that, your camera can actually become cooler than the air temperature. The moment that happens and it's reasonably humid, that's a recipe for condensation. So if you can physically block, I mean, it's kind of like, what are we trying to do? We're trying to take photographs of the night sky, but we're trying to block our view of the night sky. So it's kind of a tricky thing, but yeah, the lens hoods and especially for telephoto lenses work really well at keeping dew off. And we also probably want to talk briefly about shooting after midnight too.
Okay, I'm just here seeing the moon coming up.
Ooh.
So it's 1:40 a.m. here. We've just got the moon coming. It's going to be a little bit later tomorrow night. So for Perseids Meteor watching and for photography, maybe it's a good time to talk about that, Mike. But you know, this year is not as bad as last year. The Perseids last year, we were almost full moon, and the brighter the sky with the moonlight, the fewer fainter Perseids we can see. But it does also affect photography. How does it affect photography? What do you have to do to mitigate the impact of moonlight, Mike?
Well, there's not much you can do really other than stay home, but the moon works on the atmosphere just the way the sun does. I mean, why can't we see this? Why can't we see the stars during the day? It's because the sunlight hits the atmosphere that causes the atmosphere to glow and give off blue light. Both oxygen and nitrogen give off the same blue light. It's our physical scattering process. And that happens at night. So when the moon, if you've got these time lapses that show the moon rising, you can see the sky becoming bluer and bluer, and the detail in the Milky Way fading away. So it's really not much you can do. It's more of a kind of a glass half full. Let's appreciate what we have when we have it. And then when we have dark nights, dark Perseids meteor shower, then we'll plan something differently. But yeah, definitely there's a fine line tonight and tomorrow night between midnight and when the moon rises, because there's a fairly narrow window of real darkness. And even then the moon's pretty close to the horizon. But in any event,
you can kind of help things out by, and this is the same if you're watching the Perseids meteor showers visually, if you block yourself and or your camera from directly being able to see the moon, it's certainly going to help you watching visually, because it's as soon as you see a bright object, your dark adaptation. I mean, you can see me, I'm shielding myself from my screens. Tomorrow night doing this, you know, I probably won't see anything but the brightest meteors visually because I'm looking at the screens. My eyes need to adapt to the darkness, which they won't do because of the monitors. But it's the same with your nightscape photography, isn't it, Mike? If you know, if you're trying to capture those fainter Perseids, then point to a different part of the sky when the moon does rise, so that the moon's not in the field of view, and that's going to help you out a great deal, isn't it?
Oh, it is. Yeah, no, definitely. That's an excellent point because the, you know, just like when the sun rises or sun sets, that part of the horizon is really bright, but the opposite part of the horizon is much darker. It's the same thing. So the Earth or the moon's rising in the east, northeast, southeast, depending on where you are. And so, you know, I would suggest just facing away from that and trying to capture some of the, you know, part of the sky in the southeast. Southeast or the southeast-ish direction to or north. I mean, perhaps northeast might work too. I guess that's the thing there. It's I have to be a little bit careful if you're pointing away from the moon. It's a funny story. I got this fantastic time lapse from Death Valley. There's these salt flats in Death Valley, and I had this magnificent time lapse. I was pointing basically directly opposite the moon. I thought I had this beautiful moon reveal time lapse, and I did. Except I also had it was these perfectly flat salt flats that went out for miles, literally white salt. And I had this magnificent tripod shadow extending hundreds of feet away. It's like right when the moon came up, it back illuminated the tripod. And so it kind of wrecked everything. So just kind of be aware of that. But, you know.
Mike, we've got loads of people watching. Now, I think it's time, you know, we're 3/4 of an hour in. We know the basics of setting up. We want a nice firm tripod. You've told us the settings that we want to put on our manual settings for our DSLR or mirrorless camera. Once you've captured your images, you're saying you've got thousands of images that you took just last night from several cameras. What do you do with them? How can you process them? You know, you were talking about, you know, your meteor was looking very red. You're doing a lot of post-processing. You're not just taking the image and the camera saying, hey, there's a Perseids meteor shower and sticking it on Facebook or Twitter for the world to see. You're doing a lot of post-processing of your images.
No, that's definitely right. So let me just give you again one example. So Paul, let me try this. So cancel that. I'm going to try sharing my screen. Let me just show one example of, this was not last night. I haven't had time to do this, but this is from an earlier event.
You weren't lucky here, were you? I mean, there just happened to be a dozen.
No, this was an all-night. Yeah,
This is a composite, isn't it? You've got one, actually, that's a great opportunity to talk about non-Perseids, isn't it, as well? So sporadic. But tell us then, how on earth did you create this, Mike?
Well, so exactly. So basically here, and this is something that viewers at home can do too. I talk about this process. I have a chapter in my second book that talks about how to do this. The book's called Creative Nightscapes. But in essence, all you do is just set up your camera to shoot all night long, or as long as you can. And then you just import them into your computer. I use Adobe Lightroom. I go through and I find all the images that have meteors. And then you have to, and this can be a little tricky, but I describe a method for doing that works pretty well. You then have to align all the images to account for the Earth's rotation, because if you just, you know, composite in all the meteors from all different times of night, they're going to be flying all over the place because the radiant's moving as the Earth rotates. So you align all the images up, and then you just very carefully blend in each image. And watching them come to life like this, it's absolutely magical because, you know, you essentially align the stars in the Milky Way galaxy, as you can see here, and then you just, you know, composite in the meteor. There's no, like, you know, moving the meteor just by itself. And to see them all line up like this, like it's a little, and so again, this is looking opposite the radiant. So they're showering down on the other side of the horizon. So tomorrow night we'll give a couple examples where you're actually looking, you know, like at the radiant. So they're coming at you like Paul was describing.
How long would an image like that take for you to process?
You know, well, not as long as you might think. It's probably in total a couple, 3 hours, you know, really from start to finish. And
so that's pretty good. I mean, you're an experienced hand, so multiply that probably by 10 for a beginner.
The first time it might take a little longer, but it really isn't. I mean, it's not as bad as it sounds.
Okay.
It helps to have a good,
Have we got any questions from anybody?
I haven't checked the chat, Paul, or
No,
yes.
we've got it. Actually, let me just share my screen again because it's up on there. So,
Here we go.
anybody got any questions for Mike, or have?
Oh, here we go.
Has he told you absolutely everything you need to know? So we're going to look forward to Thursday morning, waking up and everybody sharing their DSLR. In fact, let me just do a straw poll. Those people who've got video up, put your hands up if you own a DSLR camera.
Oh,
okay, so that's a good handful. Tom's even got his in his.
great.
Grayson's got one as well. Quite a few people have got them. So how many people of those have used them for nightscape photography? So just about.
Oh, I just figured out how to see everybody. Hold on, wait a minute. Let's see what we have here.
How long you been doing this, Mike?
Not long enough.
So okay, I mean you can see that on my screen share, can't you? You can see.
Now I can absolutely see everyone. Yeah.
So okay, so you know, there's a lot of people there who have got them and who are doing them. Actually, let's do one last straw poll.
Oh, wait, stop. We have a red alert. We have a Pirate Yoda says, Mike, do you have an intro book for someone completely new to astrophotography? Yes, I do. It's this one right here. It's by Mike Shaw, available on Amazon, highly rated, quite economically priced. We can work out a deal for you to sign it, or for me to sign it and get it to you. But 440 pages.
You're shameless.
That's and then that's the intro book, and then the one that really, you know, here we go.
I want to know how much Pirate Yoda was paid by you to ask that question.
You know, yes, we'll talk.
Keith's actually showing that he's
I'm Pirate Yoda. No money changed.
Right on, Craig. Right on.
So, thank you. No, it's
no, seriously. Yeah, let me know if I can help. But seriously, I mean, there's a lot of resources, but the thing about that book in particular is it combines astronomy and photography and planning and a bunch of case studies and stuff. So.
And I have to say, you know, investing in a couple of good astrophotography books, yours included, Mike, is the best way. You know, I recommended a couple actually to our director of education, Ross Glenn, because he's getting a lot of questions, you know, and he's saying, you know, how do I find out about image calibration and flat fields and loads of sciencey bits behind what Slooh makes really easy or look easy? And I said, frankly, Russ, you know, a couple of good books, but then just be going at it, and you accumulate this knowledge over years. It doesn't take long, but the thing is, step at a time.
Yeah,
a few good books, and you know, just take it one step at a time. And I have to say, Mike, you know, your Nightscape shows are a great opportunity there, you know, for people to come in a very non-threatening environment. You know, people always feel like they can ask the most basic questions.
Oh yeah, no, that's why we're here.
Exactly, and one step at a time. So any other, so Yari's asking, Mike, with the last image, do you need to align manually every image?
Yes.
Oh, that was not the answer that Yari
sorry.
Suspect.
Yeah, it's not too bad. I mean, basically what you do, let me just explain, because it's really not that complicated, is you stack them all up in Photoshop, and then you take 2 images at a time, and you make them sort of, top one semi-transparent. And if you're lucky and you planned ahead, you've got a Polaris in both image, and you line up Polaris, and you just simply rotate around Polaris until the images line up. And then you just say, good, cut out the meteor, paste it, move on to the next one. So it's really all a matter of, and then if Polaris is not in the composition, then you have to kind of get a little bit more creative. So there's ways of doing that, but.
And Daz is saying, I have my GoPro imaging at the moment on a chance of a clear spell in thunderclouds. Yeah, Daz is over in the UK, so we've got all of these thunderstorms in there. The GoPros actually, even the early ones, are really quite effective.
Oh, they are, yeah.
If they have, it's, I think it was the 2nd gen or 3rd gen had this night mode, because I can remember we tested mine for the Aurora. when
Oh,
we were
okay.
in Iceland, and created, and because they're so easy to use, you set it off in time-lapse mode, off it chunted, and out spews at the other end this absolutely stunning time-lapse of one of the best raw displays ever. So any other questions, everybody? So what about, have you got anything left that I haven't asked you that I should?
Well, you know, it did occur to me that when it comes to the basics, there's a couple things. The first is a red headlamp is just super helpful, because if you use, like Paul was saying, if you use a normal flashlight or a cell phone, it just kills your night vision. And then the other thing I thought that really would be worth just mentioning is that a meteor shower, even with the moon, is an event that's best observed after midnight. And we'll talk about why that is tomorrow night. But I'll just say for now that it really is best. I mean, your likelihood of observing a meteor is really best between, midnight, 1 a.m. all the way through to dawn. And so it's for better, for worse. That's how it is. And so, if you stay up, stay up from 10 o'clock to midnight, and then call it a night, then you may see a few meteors, but really the most will be after midnight. So I just wanted to make that point. He already got his headlight on.
Always recommend to people, don't stay up late for a meteor shower. Get up early. It's those hours before dawn are always best. We talk about the Perseids Meteor Shower as being the most popular. It's not the best meteor shower of the year. There are meteor showers with far higher rates of meteors, but one of the reasons why the Perseids is so popular, it's visible in the northern hemisphere. It's not really visible. You might get a few, from the equator, but from southern skies, you won't see Perseids meteor showers. So here in the northern hemisphere, here I am. I'm outside. It's probably 15 to 20 degrees, something like that outside, which is very warm for the UK, as well. Except that, sweating like that. But that's why it's so popular. You get lovely, warm summer evenings.
Exactly.
You can sit out on your lounge chair, be incredibly comfortable, not get covered in dew, certainly not over here in the UK, and just have a whale of a time. The other thing I always recommend with meteor watching is do it with a group of people. It's just so much more.
Oh, it really is. It is.
And it's the same with Nightscape photography, isn't it? Like, you quite often go off, with groups of people. I know you teach people, but even when you're not teaching groups, quite often you'll go along with a couple of Nightscape buddies.
Sure. Oh, yeah. Yeah, it's a lot of fun because, there's a great, I find a great benefit in being alone at night and just out in the wild, because it's something very, primitive about that. But then there's something also about if you have just one other person or two or three other people, it makes such a difference, because, there's so much more comfort, and you're not stressing about if you're about to be jumped by a bear or something. And
we get a lot of those over here in England.
It really is. I mean, I remember one of the earliest recollections of the Perseids meteor showers. I was camping actually by myself on the shore of a lake up in the mountains in California, and I thought I was basically had the place to myself. And then, of course, once the Perseids started going off, I heard all these people around the lake, I don't know, a few miles away, just going, "Whoa!" And it was just such a community event, completely unexpected, because I thought I was out in the wilderness, but. And it's like, look at us here tonight. We're all just sitting around enjoying the Perseid planning and the science and the community of it. And it's great to see everyone, that's what makes this so much fun.
Well, one of my best Perseids meteor showers, in fact, it was probably my best experience of a meteor shower, was one that I didn't see. But it was possibly one of the most social that I've seen. And I was working at the Canary Islands Observatory. It was the Perseids Meteor Shower. It's 8,000 feet up on a volcano. That's where the observatory is. And it was my last night there, Mike. And last night is always incredibly hectic. There's always so much to finish up. It doesn't matter how much you plan, how far you think you're ahead. Last night, you're always up all night. And then literally just jump in the car and drive to the airport. what happened is everybody from the island, from the coast, drives up onto the Volga.
Oh, how wonderful.
And there's just hundreds and hundreds of cars parked up there. And I had to have my head down in the dome working on all of the equipment all night. But the screams and the hoots and the wows were just ricocheting around me. And normally it's such a quiet, peaceful place, you know.
Oh, that's terrific.
But it was an incredible experience. I didn't see them, but I still enjoyed them because I could hear everybody else's reaction to it.
Oh, that's great.
I could almost tell how bright each one was, you know, by
the crowd
volume,
meter. Yeah,
exactly. Volume equaling, you know, that. Stan is asking, what's the best time? You know, you mentioned early morning. I always think it's probably 2 hours before, you know, it starts to get light. So if I wasn't getting up for work in the morning, I'd probably get up at 3 a.m. local time for the Perseids. You can do it later for the winter showers, but for the Perseids, what would you do, Mike?
Yeah, same. I mean, essentially for us in the Northern Hemisphere, the radiant just rises all the way through dawn. So the closer you get to dawn, the higher up the radiant is, so the more likelihood you'll have of observing a meteor. It's interesting because I was actually scheduled to do a workshop in California right now that I had to reschedule, obviously. And
because you prioritize this.
Well, it worked out pretty well, actually, because one of the things I never appreciated is in Minnesota, the radiant is circumpolar. And it's, you know, in California, you have to wait, and it's like, you know, it's much lower latitude. And so I was out last night. I was like, oh, well, let's start shooting basically the moment it gets dark. And so that was, but the reason is it gets higher closer to dawn, so you're more likely to have a successful sighting.
Mike, we're going to, unless we've got any other questions, we're going to start winding up now.
All right.
I just want to ask you one last question, though, and we don't need to go deep into it, but for those people who are not fortunate enough to have a DSLR camera, you mentioned mobile phones earlier.
Mm-hmm.
Is it possible to capture a Perseid meteor on a mobile phone?
Now, that's a good question. I don't have any instances of that. I don't see why not. I think the biggest challenge would be taking enough images to have one of them contain a meteor. So I think technically it is possible because you can image the Milky Way galaxy easily. And now today it's insane. And so I think from a technical point of view, there's no reason that wouldn't happen. But from a practical point of view, again, you'd have to set up your cell phone to basically be shooting continuously all night. And I don't know if I could stay off social media that long to do that. So I'd have to get a second phone or something. But
you know, and once again, you'd need to have it set up, mounted, really,
and you'd have to exactly so
solidly.
Right.
But a lot of cameras now do have, you know, some pretty good night modes on them. And some of them do some fairly clever post-processing.
So there you go. I mean, for the app developers in the room, I mean, you have basically a few hours to 24 hours to develop the app.
Yeah,
the meteor. Yeah.
Well,
Paul and I will take like, what do you think, 5% each, 10% each, something like that? Well, we can be your technical advisors. Let's put it that way.
Yeah, we'll come up with a trade name and go off and trademark that.
There you go.
Oh, look at this, double cluster coming up.
But no, I mean, I think it's possible. It's just it would be, but you know, if there's a way to do it, you definitely give it a. Yeah. My attitude is, you know what, give it a try. You got nothing to lose.
If anybody succeeds, then share it in the Nightscapes Club, because it would.
Oh, please do, yeah.
To see whether or not that's possible. But you're also mentioning intervalometers and stuff like that, Mike. Whenever I'm doing this kind of stuff, and in fact, you know, when we're doing special events and we want people to be able to snap images from the live feeds, we tend to hook up our DSLR cameras to laptops and run software, you know, running the cameras. Do you ever do that, or is having a laptop out in the field too cumbersome for you?
Yeah, that mostly. I mean, most of my setups are pretty portable. So it's really a matter of logistics, and also just the bright glare of the laptop screen. It's amazing how that spreads. And even with a group, when we do our workshops, we really try as a group to just not use any source of light whatsoever. And it's amazing. I mean, people kind of grumble at first, but pretty quickly you realize, your eyes are so sensitive, and you can really, see a lot and get by pretty successfully without a lot of light. So a laptop kind of kills that.
You're right. I mean, there's an awful lot of equipment at the observatories which have LED lights and stuff like that, and it is absolutely remarkable, under dark conditions, just how much a single red LED on a focuser, for example, illuminates the dome. Actually, sometimes you can use it to be working by. So we basically take across all of them. Hey, listen, everybody. We are at the end. We've got no other questions. If you are not a Slooh member and you've been watching on Slooh's Twitter or YouTube channels tonight, thank you very much for joining us. Do consider hopping over to join Slooh. There's live telescope feeds every night, as we've been watching here, the double star cluster here we're looking at now.
Oh yeah, look at that.
Pretty nice. This is the one that we were talking about earlier. So it's Perseids. So in fact, Mike, the double cluster, this is very, very close, isn't it, to the radiant of the meteor shower?
It is, yeah. So this is just one of those things that you can use to help sight in, So the radiant's actually just a little bit below, sort of to the, I guess, south of the double clusters, if that helps. So
and the radiant actually does move over a period of nights, over a week. So, but anyway, listen. Thank you very much, everybody, for joining us tonight. Whether you're a Slooh member or not, do make sure that you join us tomorrow night. That is our main Perseids Meteor Shower live show. That's Wednesday, August 12th, 7 p.m. EDT, 2300 UTC. We've got live feeds coming in from our partners at the Institute of Astrophysics of the Canary Islands and our partners at the University of Sharjah, hopefully here as well, where we are going to watch these Perseids whizzing through the sky and vaporizing at 133,200 miles an hour, 60 kilometers per second. Some of the figures we're going to be talking about tomorrow night, Mike, are astonishing.
They're big numbers.
Exactly. Don't forget, if you are a Slooh member, you can join the Zoom webinar and you can interact with us. So we've still got some diehards. Let me pull them over.
Oh, and you could also, we could also throw in that, Paul and I are both very active on Twitter, Instagram, really Twitter and Instagram, I think are the two main ways of interacting with us directly. If you're so interested, you can check out my website, mikeshawphotography.com, send me an email, get on my newsletter list. But certainly it's a great time to take this time of the 2020, the year of all years. And, Slooh's a great opportunity to connect with other people with similar interests, to enjoy some great views. I know several people are still under lockdown around the world, and this is a great chance to make the connection. So thank you for joining us tonight, and please stay in touch, and certainly look forward to interacting with you in the future.
Social astronomy at its best. And in fact, our next star party is in 55 minutes time. When we've had a whole series of special star parties where we have captured each phase of the moon. And we don't usually use the enormous telescopes. Enormous telescopes are not very good because they're so sensitive, gather so much light at capturing the moon. But we set up these special missions for them for every single lunar phase. And tonight it's the last quarter moon for our special quest that everybody's working on. So we're going to be doing that in 55 minutes time. And then tomorrow night we'll be watching Perseids Meteor Shower. So it's all go 3 star parties in 24 hours.
That's amazing.
Not bad. Hey, Mike, are you back next week with your Nightscape star party? We
are. Thanks for bringing that up. Yeah, so it's Wednesday. I'm going to screw up the time, but it's check the Slooh Star Party page. And every Wednesday we have a Zoom event. It's a lot of fun. It's very, very informal. ask a lot of questions. We have a Nightscapes club on Slooh that you please join, and you can check out the images that people post. They ask questions and make observations and share information. Paul, I don't think I'm going to be joining. I'm going to be speeding up the highway in about 55 minutes to my spot. So, but I'll report back tomorrow night.
We will see you tomorrow, though, won't we?
We'll be back tomorrow night for sure. But yeah, next Wednesday, and the Wednesdays off. It's weekly on Wednesdays. We have a great community of friends now. I mean, really. So I hope to see you there.
Okay, thank you, everybody. See you hopefully in 50-ish minutes time. And we really look forward to seeing some of your DSLR captures of the Perseids meteors. Expect to see loads of those on Thursday morning. We know where you live, so we'll be round if you don't deliver. All right.
Perfect.
Anyway, take care, everybody.
Thank you, Michael.
Good night.